Okay, if you want to find all of the factors of a number, those are the numbers that basically make up that number as a product. So for the factors of 24, these are going to be any numbers that can make 24 as a product. So 1 times 24 is 24. So 1 and 24 are factors. And 2 times 12 is 24. So 2 and 12 are factors of 24. So similarly, we have 3 times 8 is 24, and 4 times 6 is 24. So all of the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. These are all of the numbers that can be written with a product to make 24. So the prime factorization is finding 24 composed as a product of just prime numbers. So the prime numbers are the numbers that they're basically the building blocks of all of our whole numbers. So, and they're numbers that can't be broken down any further, and they are the numbers that compose all of our other whole numbers. So our first prime numbers are 2, 3, 4 is not prime because it is 2 times 2. So 5 is prime, 6 is not prime because it is 2 times 3, 7 is prime, 8 is not prime because it's 2 times 4, 9 is not prime because it's 3 times 3, 10 is not prime because it's 2 times 5, 11 is prime, and 13 is prime, 17 is prime, 19, 23, and so on. Okay. So in 24, you can see the prime factors are 2, just 2 and 3. But that is not the prime factorization of 24. You want to figure out how the prime factors can be put together to make 24. So you can start with any factorization of 24. So we have 24, for example, we might start with 6 times 4. And we can ask ourselves, can these factors be broken down? Well, 6 is 2 times 3. And 4 is 2 times 2. So we see 24, and I'm going to rewrite these in the order of basically least to greatest. 3 2s and 1 3. Or we can write this with exponent notation, 2 to the third power times 3. So this is 1, 2, 3 factors of 2 and 1 factor of 3. Okay? So I want you to notice two things. One, we started out with 6 times 4, but we could have started with any other factorization of 24. So we could have started with, say, 3 times 8, and ask ourselves, okay, can we break this down any further? The 3 can't be broken down any further. That is prime. But the 8 is 2 times 4. And now we have 3 is done, 2 is done, but the 4 is 2 times 2. So we have 3 times 2, and the 4 can be broken down as 2 times 2. So again, we still have 1, 2, 3 factors of 2 and a factor of 3. So that's the first thing I want you to notice. Another thing that I want you to notice is that all of these different factors of 24 can be found within the prime factors. So for example, 2 is there, 3 is there, so I'm going to rewrite. So 1 is a factor of everything. So all factors of 24. 1 is a factor of everything. 2 is a factor there. 3, of course, is a factor there. 4 you can get as taking 2 of these 2's. 6 you could get as taking the 3 and the 2. 8 you can think of as 2 times 2 times 2. 12, let's see, that's 4 times 3, so 2 times 2 times 3. And 24, of course, is multiplying all of them. And you can even see the products. We saw 24 is 2 times 12. And we can see from this is 2 times 2 times 2 times 3, that's all of 24, and we can see the 2 times 2 times 3 is 12. Or we had 4 times 6, that's 2 times 2 times 2 times 3. So the prime factorization, this is the prime factorization. The prime factorization actually can show you any factorization of the number. Okay, now we're going to try this again and look for the prime factorization of this gigantic number. And it might seem intimidating, but I want you to notice back in 24, what we started with was any factorization at all. Okay. So when we start out with this, you might want to look for just any factorization. And so something that might jump out, well, maybe I should give you a moment. What factors jump out as something that is a factor of 16,800? Okay, for different people, it might be different things, but you might notice that this is divisible by 2. You might notice that it's divisible by 5. You might notice that it's divisible by 10 or by 100 by looking at the format of the number. So I'm going to go ahead and start with 100. So 16,800. Since it ends in 2 zeros, that means it has to be divisible by 100, and it is 100 times 168. Now already I'm dealing with much more manageable numbers. 100 I know I can break down as 50 times 2. And 168, that looks to me like it's divisible by 2. So I can do off on the side, 168 divided by 2 is 84. Okay, 50 I know is 2 times 25. We still have this times 2. We still have this times 2. And 84 is divisible by 2. That's going to be 2 times 42. Okay, then we have this 2. 25 is 5 times 5. We have 1, 2, 3 2's. 42 I know is 6 times 7. And finally, I think the last thing we need to break down is that 6. So we have 2 times 5 times 5 times 2 times 2 times 2 times 6 is 3 times 2, and then times 7. So looking at this, and I want to just rearrange it so that I have the smallest prime factors followed by the largest ones. Coming up here, 16,800 is, let's see, I have 1, 2, 3, 4, 5 factors of 2. 2, 2, 2, 2, 2, and a factor of 3, and 2 factors of 5, and 7. So you can write it that way, the long way, or you can write it with exponential notation, which is, we say we have 5 factors of 2, so that's 2 to the 5th power, 1 factor of 3, 2 factors of 5, so that's 5 to the 2nd power, and 1 factor of 7. Okay? No matter so no matter what you started with, if you started with 100 times 168, or if you started with 2 times something or 10 times something, you should have ended up with 5 factors of 2, 1 factor of 3, 2 factors of 5, and a factor of 7. And this basically shows you that, and let me back up for a minute, no matter what factors you started with, those factors will actually be seen as some combination of these prime factors that are shown here. So as an example, I could write, maybe, I could group these together and these together to find another factorization. Let's see, 16,800 is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So it's 32. Let's see, 3 times 7 is 21, and then 21 times 25. Oh, no. That's not what I wanted to do. 21 times 25. Well, let's see. 4 25s is 100. So 20 25s, 20 is 5 4s, so 20 25s is 500, and then one more, so it's 525. Okay, so I could write 16,800 as a product of 32 and 525, which I would totally not have expected that as a it wouldn't have occurred to me to multiply those two to get 16,800 just from looking at 16,800, but I can see that from the prime factorization. Okay, and basically you can take any combination of these factors, prime factors, to find some product that makes 16,800. Okay, and so that's one of the values of the prime factorization of a number. So, by the way, I just want to clarify that either one of these is the prime factorization of 16,800. This one was just a thing that we can get from the prime factorization.